What is the slope of cosine, would you say, when x is 0? Agreed. So since we're sketching the derivative of cosine, when x was 0, my slope was 0. We're talking about the derivative of cosine right now. What do you think the derivative when x is pi is?
0.
Agreed. So when x is pi, my derivative is 0. What about 2 pi?
0.
Slope would be 0. Agreed. So you cool with putting some zeros in every pi? Then I'm going to ask, give you your best shot. What do you think the slope is at pi over 2?
It's about 1.
Close.
-1.
-1. Agreed. So at pi over 2, my slope value is 1. Oh, no, -1. You got it in my head, Harville. What about at 3 pi over 2? What do you think that slope looks like? That one looks about like 1. I agree, Harvey. So now do we have my trend? Yeah, say that again, Ritz. Huh, because it is. He said, man, that kind of looks like a sine graph. Is it sine? Sine does start at the origin, but it's going...
It's reversed.
Yeah, so therefore it's negative sine. So you guys, if I were you, I'd say well, this one is y equals cosine. And then the derivative of cosine, this is negative sine. So we learned a power rule yesterday, but the power rule doesn't apply to trig functions. The derivative of cosine, we just have to know, we have to memorize it, is negative sine. Whew! So we're going to write that in a little chart. You'll see that on the next page. But I just want you to see where these derivative graphs come from. The derivative of cosine, the slopes of cosine form the graph of negative sine. Interesting. Check this out now. I'm going to do this for you. When I graph y equals x, I'm going to show you this on my little calculator. If y equals, my bad, e to the x, and you agree this is my good old e to the x, and I already graphed it for you. Check out what I can do on my y equals screen. I can say, math 8, what's the derivative of e to the x? And this is my favorite one ever, because here it is. You ready? Get ready to be amazed.
This is the same.
I have e to the x and the derivative both graphed. And what did you say, Coop?
It's the same.
It's literally the exact same. The derivative of e is the best because it's just e to the x. We don't have to memorize that one. It's kind of nice. So you guys, we've got to go graph that. So what do we remember about e to the x? If I had to make like some points, what would e to the 0 be? What's anything to the 0? 1. So when x is 0, my y is 1. And you can see that was the same value right there because that's a 5, just so you know on your scale. What about when x is 1? Does anyone remember what e's value is? 2.7. 2.718. So when x is 1, we've got 2.718. When x is 1, we're at 2.718. Boop. And then you guys, we're going to just exponentially grow. So if I were you, I would just say, okay, here's my graph of e. And the derivative of e to the x is just e to the x. We're going to fill in this little chart. This is going to be handy dandy. If my function is sine, the derivative is going to be cosine. Do we just have to have that memorized? Yeah. What's the annoying part with this one? This is the one that we graphed on the other page. The derivative of cosine is negative sine, and I think that's very easy to mix them up. But we will practice those a lot. The derivative of e is my favorite.
It's e.
It's e. The derivative of e to the x is e to the x. Oh, now this one you're going to get a little angry at. If the base is not e, if the base is some number a to the x, and I could give you an example, like that'd be the same as like 8 to the x. We'll do both derivatives. The derivative of a to the x is a to the x, just like my e, they match, right? We love that. But then we also have to multiply by the natural log of the base. You're like, well, that's annoying. And I agree. Why didn't we have to do that before? Exactly. Did we technically do this before on this rule? We did. We said the derivative of e to the x is e to the x times the natural log of the base, which is e. What's ln of e? 1. This is just 1. So we did really do the same rule, but when the base is e, we don't have to worry about it. AP does not really ask this question. If you are not a senior, Miss Meister, your college calc class will use this rule a lot. AP really doesn't. They just do it when the base is e, which we love. Sound good? So I'm not so worried about it. I'm worried about everything else. That other one, I'm not that worried about it. Okay? All right, derivative of natural log. I'm going to draw that one or sketch it. I'm going to see if you guys remember what that graph is. Derivative of natural log, boop. Whoa. Interesting. Okay, that's not really going to help us. Never mind. Okay, derivative of natural log is just going to be 1 over, and it's always going to be 1 over this value right here. So it's 1 over, in this case, x. Okay, and the last one, we did this yesterday. The derivative of y equals x. This is the power rule right there. Derivative of y equals x would be 1x to the 0, which is just, boom, uno, agreed. Let's do it right here. Let f and g be differentiable functions. I gave us some info. We had a practice problem like this yesterday. If they wanted to know h prime of 0, let's first go find h prime of x. So h prime of x, when I've got 3 times f of x, that derivative is just 3 times f prime of x. What would the derivative of 2g of x be? 2g prime of x, agreed. Minus 5 times the derivative of cosine. Derivative of cosine, derivative of cosine, derivative of cosine, derivative of cosine is negative sine. So I'm going to say the derivative of cosine was a negative sine. And to finish that up, the derivative of minus 3, 0. The derivative of a constant is 0. Good job, you guys. Now I would go plug in that x value of 0. Let's go plug in that x value of 0. H prime of 0 is going to be 3 times f prime of 0. Minus 2 times g prime of 0. Ooh, I'm going to do plus 5 times the sine of 0. Sine at 0, 0 radians. Sine e, what's the y coordinate? Bless you. 0. So this whole thing is going to be 0. H prime of 0 is going to be 3 times what? Did they give us info? F prime of 0 is going to be, thanks Tatum, bless you, 3. Minus 2 times g prime of 0. Did they give us that? 7. And then we said plus 0. Whew. You guys remember these? Here's the deal. AP is not asking you to do this anymore. They're going to ask you this question, which is not requiring us to do all of that work. But this question, we need to know what they're asking for here. This is the formal definition of the derivative. This means how to get the derivative. This also means how to get the derivative. So when they give us a question like that, we got to figure out what's the function and what's its derivative. We can do that. Do you agree this function here matches this equation? Yeah? Okay, so what we've got to get from that, extract from that, is what's my function? Here's this, and it matches that. I'm going to zoom in. Therefore, what is my function? X to the 4th. Do you agree it's not negative x to the 4th? Because in the definition, it's a minus, yeah? So Henry says my function is x to the 4th. Yes. What they're asking for here is what's the derivative without asking it in words. So now what is f prime going to be? You're done. That's the answer. So this is, I think, the hard thing about calculus. This is how they're going to use this formal definition for you. You know how to take a derivative, you guys, but they're just going to make you have to find the function and know to take the derivative of it. Let's try it again. This one, do you agree this function, now they've used this formula, yeah? They want us to take one more step here. First, here's what I'm going to tell you. We need to figure out what the function is with respect to, actually in this case, that should be a theta. What is the function with respect to a theta? Then I'm going to need the derivative with respect to theta. Then in this case, they want the derivative at a certain point, at a certain theta. And do you agree that certain theta in this case is pi? You guys, so what is the function? Do you agree it says, hey, here's my function with respect to theta? You guys cool with just saying my function is cosine of theta? Okay, so that's my function. Then we got to go figure out they didn't say go find the derivative, but they did by using this formal definition of the derivative. What is f prime if my function is theta? We just learned, if my function is cosine. Negative sign. Love it. Then you guys, what they want is they're going to say, bless you, what is the derivative of, what is negative sign when theta is pi? Whoosh. What's the y coordinate at pi? It's 0. So I'm going to say this one more time. This is going to be an AP question. It's going to look just like this, but it's going to be a multiple choicer, guarantee it. Their answers are going to be sine of pi over 3. Their answers are going to be cosine of pi over 3. Well, no, because we would simplify it. Their answers might be 0 over 0, might be undefined, but what they want you to do is go extract the function with respect to x, go take its derivative, then go plug in that x value. Pi over 3, pi over 6, pi over 4, pi over 3. Cosine, what's the x coordinate up there? 1/2, very good. My answer is 1/2. Okay, you guys, which one did this one use, left or right? Ooh, it used the left one. Be careful, is my function, my f of x, 1/2 or is it 1 over x? It's 1 over x. So we've got to say, oh, geez, my function is 1 over x. They want the derivative. Guys, we can't take the derivative of that when it's written like that. How am I going to rewrite that so I can use that power rule?
X to the negative 1.
X to the negative 1. Boom. That's up here because that's still my function. What's the derivative of that? Negative x to the negative 2. You got it. Is that really negative 1x to the negative 2? Yeah. How am I going to rewrite that? What gets moved down? Only the... Exactly. Only the thing with the negative exponent. So my derivative is negative 1 over x squared. Now, where do they want that derivative when x is 2? And I think that's really hard to take that 2 out of it in the beginning. When x is 2. So we'd have a negative 1 over 2 squared. What's my derivative?
Negative 1/4.
Yes, sir. Okay, I'm going to actually back this out so you can see that, the definitions are down here too. Okay, which one? If it's h is approaching 0, definitely this formula. What's my function? So don't forget, my function is, we're seeing a 1, but they've simplified something. My function when x plus h just gets me e to the h. What would be my x coordinate if, yes. So he's saying, wait a minute, if my function, and I'm going to write this here, if my function is e to the x, if I plugged in x plus h here, and I'm just left with an h, wouldn't my x have to be 0? 0 plus h would get me h?
And e to the 0 would be 1.
Yes, and e to the 0 is 1, exactly. So if my function is e to the x, what's the derivative? We love e. E to the x, I love it. And then what they're asking for is my derivative when x is 0. Because just like Ku said, h plus 0 is just h. E to the 0 is just 1. So when I plug in a 0 here, e to the 0, done.